Hello everybody, welcome to the Chapter 7 review where we're looking at exponents and exponential functions. A lot of simplifying, a lot of working with our numbers. So let's go ahead and look at negative 3 to the fourth power because the exponent is outside of the parentheses and the parentheses is including the negative. That means we are taking the negative with us. That means this is negative 3 times negative 3 times negative 3 times negative 3. And in that case, all of these, negative 3 to the fourth power ends up being positive 81. A negative times a negative times a negative times a negative ends up being 81, a positive number. Let's look at number 2. Now notice the exponent is attached only to the base number of 3 and not the negative. There's no parentheses on this one. So this is saying negative times negative of 3 times 3 times 3 times 3. So this one equals negative 81. I'm going to just have the exponents influence the 3 and the negative later. When we look at number 3 here, a little different. This negative exponent is telling us that it is a small number, not a large number, so we can represent this one as 1 over 3 to the fourth. So that negative here is telling me that it indeed is a fractional amount. So 1 over 3 to the fourth simplifies to 1 over 81. This one, same situation. So this negative here tells me that it's small. This negative here tells me that it is negative, but it's in the parentheses, so I need to pay attention to it. This is still going to play out as, because it's small, it's a fractional amount, it's still going to be in the parentheses to the fourth power. So this plays out as negative 1 over negative 3 times negative 3 times negative 3 times negative 3 because of the parentheses. So this ends up simplifying to 1 over 81. Again, just because a negative times a negative times a negative times a negative will be positive. So a couple things to keep an eye on is a negative exponent will tell you that the value is small. A negative base will communicate to you if your answer is positive or negative, so kind of what side of 0. So the exponent tells you what how far from 0, and the value of the base tells you what side of 0. Okay, let's look at some other ones here. Now I've got these exponents because we're multiplying them together. Technically this is saying 5 times 5 times 5 times 5, 2, 3, 4, 5, 6, which means that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 of them, 5 to the 9th. Another way to look at this would be if they have the same base and you're multiplying them, you are just adding the exponents. So when we look at number 2, we do have the same base of x, so it is multiplying, so I can just add the exponents. So it ends up being x to the 6th. Now for number 3, it is x to the 4th to the 3rd power. It's a little bit different. This is saying x to the 4th, and this is asking me to multiply by 3. So this is x to the 12th. When you have this particular situation, you are multiplying them together versus the last situation where we added them. This time I'm taking 3, and for number 4, 3 times a to the 3rd power squared. So the square is going to influence the 3 and the a to the 3rd. So I've got 3 to the 2nd times a to the 3rd squared. And if you remember what we did like on our last problem, we're going to multiply those together. So 3 squared is going to be 9, and it's a 3 times 2, which is 6, so a to the 6th power. So with exponents, we just have to pay attention to a few of the details of these. All right, so for these guys here, when I'm multiplying all these guys across, I need to find all my like terms. I mean, really, this is negative 2 times x times y times 5 times x to the second times, and so forth. So if I look at this as one big, long multiplication problem, I need to do some grouping here. I'm going to look at my, let's just look at my x's first. So, well, I could do these. So negative 2, and I've got a 5, and I've got a 3. So negative 2 times 5 times 3, I end up with negative 30. Let me look at my x's. So there's an x. There is x squared here, and here's x to the third. Now, if I was adding all these together, I have to look at it differently, but because I'm multiplying, this is saying x times x times x times x times x times x, which is telling me it's x to the 1, 2, 3, 4, 5, 6th power. Now I'm going to look at the y's. So there's a y, there's 4 more, and there's 8 more. So it is going to be y to the 1 plus 4 plus 8. So then it's going to be y to the 13th power. So it ends up being negative 30 x to the 6th power times y to the 13th power. Same thing in number 6. Looking at everything that's similar. So I've got a 5, a 3, and a 1 here. So 5 times 3 times 1, I get my 15. Let's look at the x's. So here's x to the 4th, x to the 5th, x to the 4th. So it's x to the 4th plus the 5th plus the 4th. And I've got y here, I've got a y here and a y here. So it's y to the, I've got the 9th, I've got a 1 right here, and a 2. So this simplifies to 15 times x to the 13th times y to the 12th. Let's look at number 7. Consider pressing pause and working through these and then continuing on the answer just so you can see how you're doing on some of them first. So for this guy, we've got a cubing here to do, so I've got to cube everything, all the pieces here. So this becomes 2 to the 3rd power times x, 3 times 3 times y to the 3rd times, and I'm squaring all the pieces here. So that's negative 4 in parentheses, because I'm doing the whole thing to the 2nd power, times x to the 4th to the 2nd power, times y to the 5th to the 2nd power. And simplify all these. 2 to the 3rd power, end up with 8. X to the 9th, y to the 3rd, times negative 4 times negative 4 is going to get me to 16, times x to the 8th, times y to the 10th. I do some combining of like terms, so actually it's multiplying, not even adding them. So 8 times 16, I end up with 128. I look at my x's, and I have a 9 and an 8, multiplying them together, so I end up with x to the 17th power. And I have my y's, which I have 3 over here and 10 over here. So it's y to the 13th. That's how that plays out. So when I simplify number 7 here, I end up with 128 times x to the 17th times y to the 13th. Okay, let's do some more distribution on this one. I am going to take each one of these pieces to the 4th power. So this ends up being negative 2 to the 4th power, x to the 2nd times the 4, y to the 5th times the 4. Negative 2 times negative 2 times negative 2 times negative 2 ends up being 16, x to the 8th, y to the 20th. Now this guy's interesting because it's all of this to the 0 power, and anything to the 0 power ends up being 1. I'm going to pay attention to my negative out here, so it's negative 1, negative times 1, which ends up giving me negative 1. So be careful on that 0. Number 10, we're going to look at some division here. I can look at it as its different pieces here, so I'm going to do some simplifying. So I end up with 24 over 6. I'm going to look at this guy right here, which is a, and I'm taking my numerator, and because I'm dividing, it's going to be subtraction. So a minus negative 2 And then let's look at the b here, and it's going to be b with the 4 minus 7. And I can simplify this out even some more. 24 over 6 ends up being 4. A to the 5th minus 2, I end up with a to the 7th. And then I end up with b to the 4 minus 7, which is negative 3. And on this one, right here, um, don't leave this. So I gotta tend to my negative exponent here for simplifying. Because it's negative, it means it's little. It's small, it's going to be a fractional amount. So I take my 4a to the 7th, and I bring my b to the 3rd to the bottom of my fraction, representing it as a small amount. And there is my simplified form of number 10. Let's take a look at number 11. Oh, we got all kinds of stuff going on here. We got squaring, we got dividing. Whew, kind of fun. So let me square all the terms. Okay, so I end up with 9. A to the 2nd because I'm squaring that. And b, I'm squaring this one, so it's negative 3 times the 2. So it's going to be negative 6. I'm going to go ahead and cube all the pieces in here. So 3 to the 2nd, or 2 to the 3rd power is going to be 8. A to the 3rd times the 3 is going to be a to the 9th. And I'm left with b to the 3rd. Okay, because this is negative, it's a fractional amount, I'm going to bring it to the lower part of the fraction. So I'm going to take this piece and bring it down here. So it ends up being, I'm left with 9a to the 2nd over 8a to the 9th, b to the 3rd, and b to the 6th. And I can bring these together. So I end up with lots of room here. So a to the 2nd, a to the 9th, and b to the 9th. Okay, can do a little bit more simplifying here. Let's see. 9 over 8 is not going to simplify. Right here, this is going to simplify though. That is a to the 2nd minus 9, and so that leaves me with a to the negative 7. So that's going to stay in my denominator. So I'm left with, and then the b is going to stay right there too. So this all simplifies to 9. And that's it in my numerator because I simplified that out. And on my denominator, I'm left with 8. And a to the 7th, which is coming from here. And b to the 9th, which is staying. There is my simplified form. Some people might write it as 9/8. Another way you could write this one would be 9/8. 1 over a to the 7th, b to the 9th. But this is a better way to write this. All right, let's take a look. Number 12. Wait, number 11 took a lot of space. Number 12. This probably will too. I'm going to simplify my 2 and my 4 early. These guys right here, I'm going to simplify those out early. This 2 ends up becoming 1, and this 4 becomes a 2, so I can avoid some of those steps. So my numerator will stay the same because it's the first power. My denominator does change though, so I'm going to rewrite my numerator. But my denominator does change because I'm doing some squaring. So x to the 2nd to the 2nd power becomes x to the 4th. Y, the negative 3rd times 4 is going to be y to the negative 6th, because it's not times 4 times this 2. Okay. Now, because of this negative, it's actually going to take this term and bring it to my numerator. It kind of shifts directions, so let me rewrite it. We can take a look at it. So 4x to the 5th, y to the 7th, that's what my numerator was, but my y to my negative 6th comes up to the top. To my numerator, I'm left with x to the 4th at the bottom. I can simplify this out to 4x to the 5th, y to, I can add these two together, end up with y to the 13th over x to the 4th. These guys right here will do some simplifying to x to the 5th minus 4, because it's basically saying x times x times x times x times x over x times x times x times x. So we can do some cross simplifying on that one. Let's see what we end up with. So x to the 5th minus the 4, I'm left with 1x. So my denominator actually goes away. So I'm left with, simplified out, 4 times x, so that's what's left, times y to the 13th is my final answer. So for these problems here, the main thing is just paying attention to the details. When that exponent is negative, it's going to shift to the other side of the fraction. Also keep track of when you are um, like subtracting negatives. Just keep an eye on the subtracting negatives. Number 13 here. Okay, so this is different because we're not multiplying, we are adding and subtracting. Okay, so x to the 4th, that ends up being x to the 12th, y to the 6th plus, I'm going to square everything in here. So I end up with 25 x to the 12th, y to the 6th. Now because I'm adding, I'm going to combine like terms, and my term is x to the 12th, y to the 6th, x to the 12th, y to the 6th. So I can bring these together. On my right side there's one of them. On the left side there's one of them. On the right side there's 25 of them. I can bring them together and I can see that I have 26 x 12 y to the 6's, and that's my final answer. If I look at number 14, I need to do some squaring, and I end up with x to the 16th, y to the 4th plus. I need to do some quadrupling to four things here, or three things. I end up with 16, x to the 16, y to the 4th. Looking for common terms, so x16 4, x16 y to the 4th. I can combine like terms. I have a 1 here, and I have 16 here, so a total of 17, x to the 16th, y to the 4th. And that is my final answer. Now remember, the main thing for these guys is when you're adding and subtracting, they have to have same last names. You're combining like terms. So what do we got here? Ooh, you know what? These are actually not in scientific notation. They're in powers of 10 though. If they were in scientific notation, the 2 and 4. Oh, you know what these are? Because the 2 and 4 will need to be, your first number need to be between 1 and 10. So these are indeed in scientific notation. This guy right here is not though, and number 16. It's not in scientific notation. If I wanted it in scientific notation, I'd have to make it 6.4 and then change my power of 10. But let's go ahead and keep simplifying this. Let's see. So for these guys, I can take my 2 and my 4, multiply them together to get 8. I can take my powers of 10, and I can combine them. So I have my 7, and it's times 9, so I'm adding them together. I end up with 8 times 10 to the 13th power. Same thing is happening over here. 64 and the 3.2. Now I'm going to take the 64 and 3.2, and I'm going to, on the side here, multiply both of them by 10 so that I can end up with 640 over 32. Helps me see a little bit easier what math needs to happen. 32 goes into 64 twice with 0, so I know right now that this simplifies to 20. Now I can deal with my second part here. This is going to be, so right now I'm left with 20 times 10, and I've got my 7. It's dividing, so it's minus, and I've got my 9. So my answer is going to be 20 times 10, 7 minus 9, which is going to be negative 2. Now if I do want this in scientific notation, I need my first number here to be between 1 and 10, so I'm going to move my decimal over one place over, so it ends up being 2 times 10, and I have to compensate my exponent. So pay attention to see if the answer. If I wanted an exponential, if I wanted scientific notation, it would have to represent this way, or if I just ask you to simplify, you could write it this way. So keep an eye on that detail. Whew. So last page, we're looking at these guys. So you have fractional exponents. Now this is in 7.5. So this is one maybe to look back at in your book. Okay, a couple things to let's see. Let's take a look at this. So 8 to the 2/3 power. This is also saying 2 times 1/3. That's what that exponent is also telling us. When we say 8 to the 2/3 power, we're seeing this. It's 8 squared to the 1/3 power. That's why we were looking at this and this. It's 8 squared to the 1/3 power. So how that translates out is that's looking for the cube root of 8 squared. Ends up being the cube root of 8 squared. So this number right here ends up becoming this part, which ends up becoming my index. That's kind of that fancy name for that. So actually my answer number 17 is the cube root of 8 squared. That's what ends up being. All right, just kidding, because I can see here that I can simplify this more because the cube root of 8 squared is 64. Yeah, 8 squared is 64. And the cube root of 64, so what times what times what is 64? That actually is 4. So 8 to the 2/3 power is 4. Let's keep going. The plot thickens. Let's look at 81 to the 3/4 power. Now, something to keep in mind also with these guys is, like for instance, 81 to the 3/4 power is the same as the quad root of 8 to the 3rd power, which is also equal to the quad root of 81, all of that cubed. Okay, and that's helpful in this situation, and you'll see how that plays out here. Okay, so that being said, this ends up being, so like I said, the quad root of 81 to the 3rd power, which is equal to the quad root of 81, all that to the 3rd power, and that is equal to, let's see, so the quad root of 81 is 3, and that's to the 3rd power, which is 27. Okay, so in this situation, it was good to utilize what I know here. Maybe on the first one, not so much, like in number 17, but in 18, it did, because I could get to a quad root of 81. I could also work on 17. Maybe you can try it out and see if that happens. Let's take a look at number 19. Let's see, for 27, I go ahead and I distribute out to the 3rd power, and I end up with the cube root of 27, and that's to the 1st power, times x to the 5/3 power. The cube root of 27 is 3, and so I end up with 3x to the 5/3 power, and that indeed is simplified. Number 20. Before I do number 20, we should keep in mind that like square root of 25 is equal to 5. Okay, true. And that's also equal to, when I say square root of 25, that does have an index of 2. We just usually don't write it in there. That is equal to 25 to the 1/2 power. So all of these pieces right here are equivalent to each other. So it's a good way to look at all these different notations. Square root of 25 is equal to 5, which is equal to an index of 2. So again, that's still square root of 25, which is equal to 25 and a half. Something to keep an eye on. All right, let's take a look at number 20. I need to do the cube root of 64 and the cube root of x to the 5th power. So the cube root of 64 times the cube root of x to the 5th. Cube root of 64 is 4, and I end up with x to the 5/3 thirds power again. I think that's it. That was a doozy. Whew. Well, it's been fun hanging out with you for 25 minutes. I'm going to go eat a sandwich. I'm going to eat it upside down.